Hello and welcome back to the alphabet of astronomy. So today is brought to you by the letter K, and K is for Kuiper Belt. So most of us know about the asteroid belt that's in between Mars and Jupiter, but did you know that there's another even bigger belt in the outer portion of the solar system? And this is in fact the Kuiper Belt. So these are small objects that are located out beyond Neptune, and because it's so far out in the solar system, they're going to be very cold. They're generally icy objects. And so if they do end up getting disturbed into the inner solar system, they can actually create comets as the icy material begins to evaporate and sublimate as it passes closer to the sun. The Kuiper Belt lies between about 30 to 50 AU, or 30 to 50 times farther from the sun than the Earth. And it contains much more mass than that small inner asteroid belt, up to hundreds of times more. But still, it doesn't contain more than 10% the mass of the Earth. So spread out among all of these different bodies, they're relatively small. The Kuiper Belt is named after Dutch-American astronomer Gerard Kuiper. He was not the first to predict the existence of this sort of belt in the outer system, but he was one of the first, and so it's generally named after him. Now, even if you haven't heard of the Kuiper Belt, you've probably heard of the largest Kuiper Belt object ever detected, because that is Pluto. Yes, in fact, Pluto was discovered in 1930, and now we know that it is one of many objects in this region that we call the Kuiper Belt. Now, after Pluto's detection in 1930, the next Kuiper Belt objects were not detected until 1992. So we went for a really long time not actually knowing about these other bodies out there, even though we thought they might exist. And so this is one of the reasons that basically our understanding of Pluto's place in the solar system has changed, because now we've actually detected thousands of bodies within the Kuiper Belt. And it's estimated that there could be hundreds of thousands of bodies that are greater than 100 kilometers in size in the Kuiper Belt. So Pluto, while he is the biggest one that we know of in the Kuiper Belt, is still just one of many objects, similar to Ceres in the inner asteroid belt. Objects in the Kuiper Belt, or Kbos for Kuiper Belt objects, are also sometimes called TNOs for trans-Neptunian objects, because trans-Neptunian means that they are out beyond Neptune. However, the TNO label is somewhat larger than the KBO label, so anything that is a body out beyond Neptune is a TNO. But only certain things are Kuiper Belt objects. Now, Neptune isn't just a neighbor to the Kuiper Belt. It's actually a very important part of the formation and structure of the Kuiper Belt. This is because the structure of the Kuiper Belt is dominated by resonances with Neptune. So when we're talking about resonances, orbital resonances, we basically mean when the orbits of two objects have basically integer multiples of one another. So for example, Pluto and Neptune are in a resonance. They are in a 3-to-2 resonance, which means that for every 3 times Pluto orbits, Neptune orbits twice. And that always happens because they're integer multiples. So 3 Pluto orbits, 2 Neptune orbits. Now, this sort of resonant configuration can kind of protect these bodies from being scattered out. Even if they're on orbits that are crossing the orbit of Neptune, like Pluto's is, it still can be very stable because of the resonance. But it can be very unstable close to the resonance. So the resonance can both protect bodies that are in the resonance and also deplete bodies that are close to the resonance. There are actually many objects that are in this 3-to-2 resonance with Neptune, and we call them Plutinos, named after, of course, the first one that we knew, which was Pluto. Now, if you move out farther, you get to what would be the 2-to-1 orbital resonance with Neptune, so basically double Neptune's orbit. And at this point, the density of the Kuiper Belt falls off dramatically. This is actually called the Kuiper Cliff, and the actual cause of this cliff isn't really known, and it's not known if it's just a gap in the belt or if it's actually the end of the belt. It's pretty interesting stuff that we're still trying to figure out in our own solar system. And the structure of the belt isn't just dominated by current Neptune. It also tells us something about what Neptune was like in the past based on the structure that we see today. So for example, there's a relative emptiness of objects inwards of about 39 AU in the Kuiper Belt. And this isn't explained by the current configuration. So Neptune's current resonances shouldn't have depleted that portion of the belt. So what astronomers think happened is that Neptune actually migrated outwards, and as it moved, it kind of depleted those sections of the belt as the resonance was moving through there until it arrived at its present current configuration. And so it cleared out those objects, and so that's why there's still a gap that we see today, even though it would be consistent with Neptune's current orbit to have objects there. Now, the majority of the Kuiper Belt is what we call the classical Kuiper Belt, and this basically means this is where they classically predicted the Kuiper Belt would be. And this classical Kuiper Belt is split into 2 different populations, the hot and the cold. And this has nothing to do with temperature. They're all cold. It's out beyond Neptune. It's cold. So this is actually actually referring to their dynamical behavior. So dynamically hot objects have been basically stirred or disturbed by some sort of interactions. They've been heated by interacting with other bodies. So they have these kind of disturbed orbits that might be more eccentric or more inclined to the plane because they've been interacting with other objects. And in contrast, these cold dynamical objects basically haven't interacted very strongly with anything, and so they're just on kind of these plain, boring, circular, in-plane orbits. I mean, we love these orbits, but they're cold. Some other KBOs are considered resonant KBOs, which would be the ones that are in a resonant configuration with Neptune, as we've discussed. There's also detached KBOs, which are basically far enough out and with low enough eccentricity that they really never interact with Neptune at all. And then there's something called the scattered disk. Now, the scattered disk extends much farther out than the Kuiper Belt, but it overlaps with the Kuiper Belt, and the Kuiper Belt might be the source of some of these objects in the scattered disk. It's called the scattered disk because objects get placed into the scattered disk by scattering off of the giant planets in the solar system. Now, when we talk about scattering, it doesn't mean like a literal collision. It can just be a gravitational interaction when it passes close to one of the planets. So we've detected thousands of KBOs now, but it's really difficult to do because we're talking about the very outer reaches of the solar system where things are just not very bright because there's not a lot of sunlight. And so it's very hard, and these are very small objects, so they're very hard to detect, but we have done it. And our scientific knowledge was greatly increased by this wonderful little mission called New Horizons, which you may have heard of. So this was a NASA mission. It launched in 2006, and its primary target was to visit Pluto, which it did. It flew by Pluto in 2015, and greatly enhanced the images and science that we have of Pluto, and people are still studying the results from the New Horizons mission to learn more about Pluto. One of the most exciting Kuiper Belt objects for a lot of people. But it didn't stop there. So after it flew by Pluto, scientists selected a couple potential secondary targets, and eventually it was chosen to fly by a particular KBO, and it flew by in January of 2019, this object called Arrokoth, which I like to think of as the Kuiper Belt snowman. So this is actually what's called a contact binary because it's a binary object that's physically in contact, not just orbiting. Actually, a lot of objects in the Kuiper Belt are binaries, and this is kind of a relic of the formation of the Kuiper Belt, which is still an actively researched question, exactly how the Kuiper Belt formed, but we do see evidence for Kuiper Belt-like structures in other solar systems, other stellar systems, I should say. And so we think that the Kuiper Belt is kind of a natural outcome of planetary formation, and that they're kind of leftover building blocks from the protoplanetary disk. So they're planetesimals that never quite managed to come together and form a larger planet. And probably because of the presence of Neptune. So Neptune kept those planetesimals so stirred up that they could never really merge and form another larger planet. So there's a lot of really cool objects in the Kuiper Belt. I don't really have time to talk about all of them, but I did mention Pluto, so I want to also mention two other very large Kuiper Belt objects called Makemake and Haumea. I'm probably pronouncing that wrong, so I apologize. In any case, these are both dwarf planets like Pluto that are located in the Kuiper Belt. And I think Haumea is especially cool because it is not spherical. And I don't mean not spherical in the sense that it's not massive enough to become a sphere under its own gravity. And I don't mean non-spherical in the sense that, like, you know, a lot of planets, because of the way they spin, their equators are slightly larger than their poles. It's like that, but way more extreme. Haumea is spinning so fast that it's basically kind of turned itself into this egg-like or football-like shape because of its spin. And yeah, I just think that's cool. So yeah, so Pluto, Makemake, and Haumea are the three largest KBOs that we know of. There is actually a larger object called Eris. It's even more massive than Pluto, but it's a member of the scattered disk, so it's a TNO, but not really a KBO, depending on how you want to classify these things. All right, so that's the Kuiper Belt, a very large belt of asteroids and comets in the outer solar system that we are still studying and is very exciting part of our solar system. I hope you learned a little bit of something. Thank you so much for watching, and I hope you'll join us again for the letter L. Thanks, bye.